Hi everyone, I'm Kenneth Huang from Penn State University. Today I'm going to talk about how we use non-expert crowd workers to annotate 10,000 scientific abstracts relevant to COVID-19 reliably and rapidly. So this is a collaborative project with Dr. Giles at Penn State and my own PhD student Chieh-Yang Huang. We also work with Cornelia from UCSF and Yen-Chia from Carnegie Mellon University. So in today's talk, I hope we could convince you that you can use non-expert crowd workers to annotate scientific abstracts reliably. And the motivation of our work is pretty similar to many other work presented in this workshop. The CORD-19 dataset alone has more than 100,000 papers, and it is just very hard for any individual to read all the papers and understand all the content. The high-level theme for me is to manage the information overload. You create QA system, you extract information, you build search engines, you generate summaries to handle the information overload. In this paper, we focus on one particular solution, which is to highlight the structure of papers. By highlight the structure of papers, we mean that if someone annotate the background, the motivation, the method, and the findings on paper abstract for you, it will probably make it easier, a lot easier to find critical information you want, right? And by research aspect, in this paper, we actually use a 5-class annotation scheme: background, purpose, method, finding, and other. So as an NLP researcher, you might think, okay, I'm going to build a classifier or annotator using deep learning. However, to reach to a really good performance, you really need human annotated data. And who is going to create that data? In many prior work, they asked professors, researchers, and PhD students to annotate scientific papers, which is expensive and can be very slow. So in this paper, we asked a slightly different question. How about using non-expert workers to annotate scientific text, right? And we are not the first person to think about this. For example, in 2018, this CSCW paper tried to use non-expert crowd workers to annotate the background, purpose, mechanism, and findings on scientific papers. However, the concern is actually the quality. Based on their work, the token level agreement rate done by mechanical Turk workers is only 60%. And if that's the quality, it's not really usable to train a good classifier or data annotator. So in our work, we actually try many things to make sure the data quality is good. We created the video tutorial. We created interactive tutorial to teach workers how to use the interface. And we formulate this problem as a sentence classification task, so the workers don't need to decide the boundary of the annotations. And we also post tasks to Mechanical Turk in small batches. Every single day, we only post 500 or 1,000 paper abstracts so that we can closely monitor the data quality. We also work with 2 experts who provide a small set of expert annotation for us every day, so we can use the expert annotation to monitor the data quality. And if we see anything wrong or weird, we'll actually send email to workers to inform them and give them some feedback. And finally, we decided to collect 9 labels for each sentence and aggregate them using majority voting. So this is our interface. And at the beginning, we will show the definition of research aspect. We also have a list of FAQ. And the main annotation interface looks like this. The worker needs to go through each sentence one by one to choose the corresponding category for that sentence. And finally, we also provide this interface so workers can review and navigate the annotations he or she just created. If the workers see anything wrong, they can go back and fix them. So let's take a closer look. So in the step 1, we ask crowd workers to spend 10 seconds to take a quick glance at the entire abstract, right? The goal is to get a high-level sense of the topic so that they know what they're annotating. And in step 2, actually the worker need to go through the sentence one by one to select from background, purpose, method, finding/contribution, and other. Furthermore, you can also see or provide a clear visual feedback for workers so that they know, okay, this sentence has been annotated, you should move to the next sentence. So if they are not happy with a previous annotation, they can actually go back and fix previous annotation. And finally, we provide an interface that worker can navigate their own annotations to see if there's anything wrong. So in the actual data collection setup, we randomly sample 11,000 abstracts from CORD-19 dataset. This collection contains more than 100,000 sentences, and 248 crowd workers from Amazon Mechanical Turk participated in the data annotation process. And it took us about 10 days from April 19 to April 29. And on average, each abstract costs $3.2. This project is supported by 2 seed grants from Penn State University, and given the budget, we can afford to annotate around 11,000 abstracts. This is one actual example annotated by crowd workers. And if you are interested in seeing more details, you can go read our paper. So now we know crowd workers can annotate a lot of papers relatively rapidly, right? So how about the quality? So like I said, we work with 2 experts. So we use the expert annotation to evaluate crowd label quality. It turns out the accuracy and the kappa is reasonably high. The accuracy on average is 82% and the kappa is 74%. It's pretty reasonable. And to contextualize this number, we compare the performance between 2 experts. The accuracy and the kappa is actually just slightly higher, which gives us more confidence that the data quality is pretty reasonable. Equipped with this dataset, this large dataset, we created several baselines try to automate the annotation process, right? And it turned out the Steinberg gave us the best performance. The sentence level accuracy was 75%, which is a good starting point. In this experiment, we only use the text inside the sentence. We did not use the title of the paper. We did not use the full text of the paper. We did not even use the position of the sentence to further boost the performance. If you go with those extra contextual information, you could probably further improve the accuracy. And if you're interested in doing that, please go to CODA-19.org to get all the data, all the annotations, the code, and the model from our GitHub. So I hope in today's talk, I convinced you that you can use non-expert crowd workers to annotate scientific abstracts reliably and rapidly. So what's next? So currently, we are working with Dr. Li Zhao's group and building a research engine called COVISEER. And our plan is to incorporate research aspect into the search engine. And hopefully, that can help users to find the information they need. If you are interested in collaborating or you have any questions, please email me and I'm happy to answer any questions. Thank you very much.